Fine. So so before I start off today's discussion, right, a very quick thought on the bimodal distributions. Now, if you look into mode as a measure of central tendency, right, you will see that it considers the most highly or most frequently occurring value as a, as a central measure, right? So over here, what you have is uh, over here, the greatest importance or the greatest emphasis in the recovery distribution is on the 0 and the 1 because it's a bimodal distribution as we have seen. And it is pretty kind of convenient and it's pretty kind of intuitive that yes, in most of the cases the recovery should be concentrated at these two ends. But when but given that this recovery would be a dependent variable in your model, you cannot have it in such an irregular fashion. So what you need to do is you need to perform a transformation exercise and smooth out this irregularity in the distribution. And to do this and to sort this irregularity out of the distribution, what you need to do is you need to do a transformation, you do a Box-Cox transformation, right? And the entire idea of this Box-Cox transformation is to assign a lower weightage to the peak values and or to the lower values and sorry, assign a higher importance to the lower values and the lower importance will be higher values such that such that you know the value of the distribution more or less regularizes. Now the question that comes out is that given that I have done the transformation, the next question for me is how is it that I would model this loss given default? What are the different ways of modeling the loss given default? Right? So over here in terms of linear in terms so basically what we saw was that we there are three broad approaches of developing this loss given default model. And so what are the three broad approaches? One is your linear regression, the other is your logistic regression, and the third is your beta regression. Right. So what we do is now one interesting factor about LGD is that not for retail but for the commercial LGD models, the role of macroeconomic variables may also come in. Right. So one thing that we see is that regression models from our previous discussion, you can see that regression models are one is a set of statistical measures which can help me take care of developing logistic which can help me take care of LGD model development, right? So this is so over here. The question that comes out is the first one of the biggest question is what is regression? So what is regression? Right? So there is linear, logistic, and theta. So these are the different types of regression depending on the distribution of the dependent variable. But let's try to understand like what exactly is regression as a modeling methodology. Why am I saying that I would use regression? What is it all about? Right. So once we have an understanding of regression, right, So then we'll start talking about linear regression and a logistic regression. Now, what regression does is regression estimates causality. It estimates causality. Now, the question that comes out over here is that what exactly is then causality? What is causality? The causality is where X is causing Y. So, what is causality? Causality is that X causes Y. So, X is an independent variable which is responsible for causing Y. But on the other hand, Y does not cause X. X can cause Y, but Y cannot cause X. Right? So basically, what we are trying to understand is one-sided or a single or unilateral causality. So basically, when we talk about regression models, so there are regression models, the structural equation models, which are given advanced form regression models, where you talk about two-way causality, right? But over here, we are trying to talk about unilateral causality. Unilateral causality. Unilateral causality. So basically, I want to know whether X is impacting Y. So basically, this is nothing but it is written as Y equals to f of X. So that is Y is a function of X, where X is an independent variable. Now there would be multiple independent variables. So when you are actually exploring this causality in an econometric framework, right? So that framework is called regression. So in regression, what we try to do over here is we try to assess the unilateral causality between x and y, where x is an independent variable, y is a dependent variable, and the entire objective is to identify the average impacts. The average impacts of change. Average impacts of change. Of change. So over here, when I'm trying to assess, the impact, I'm trying to looking on that on an average, how would X impact Y? And that is precisely what the regression framework is. But the biggest challenge of any econometric framework is the existence of the following term. Let's say I say that y is equal to a plus bx. So what I'm saying over here is that y is impacted by x. So when x would change, y would also change along with x. Let's say the objective, my dependent variable is recovery. Now, recovery would change with a change in the, the collection costs, right? Or with the collection revenue patterns. So basically, the recovery that I am able to make, right, would obviously be driven by, it would be driven by multiple factors, right, which explain the recovery. But apart from that, it would also be determined by something called an error term or something called a white noise. So over here it says there will, in addition to this factor x, there will always be a ui or a ei, which is the random component. So what we are saying is the observed value yi for the observed value y for an ith observation is comprised of two parts. Number one is a plus is the deterministic part, and the second is your random error part, right? So that is what we need to understand over here. So over here, what we are trying to do is we are trying to do the following. So what we are saying is that the observed value of a dependent variable yi is driven by two components. One is the deterministic component, okay. So as I was saying, that with yi, so the observed value of a dependent variable is comprised of two parts. One is your deterministic component, and the other is your random component, right? Now, the random component. So let's say, so how do I relate this concept of a deterministic component and the random component with LGD? So what type of cases we would be having when we are talking about the deterministic component and the random component? Let's say I'm trying to estimate the LGD, or my objective is to estimate the recovery, right? Now, to estimate the recovery, one of the important facts would be, so to estimate the recovery, one of the, okay, okay, fine. So as I was saying, so let's say that there is a recovery, right? So what I'm trying to tell you is that, okay, this is yi is the dependent variable, so that's recovery. Now, with recovery, so what are the factors which would drive my recovery? Now, if I go back a few couple of pages, so when we started our discussion, we talked about an equation of the LGD model, right? That there are certain factors which drives the LGD of a date of a of a borrower. So what were those factors? So some of the factors that we have over here is, so some of the factors that we talked about at that point of time was that it involved the recovery characteristics plus the firm characteristics plus the macroeconomic variables, right? So, so these variables or these set of variables that you are seeing are deterministic variables, right? Let's say a firm. So when you are trying to understand the recovery that you are going to make from a firm, you're trying to estimate that. So what type of firm characteristics comes into play? Now, the type of the firm characteristics that would come into play is obviously the rating of the firm. So you understand that he has defaulted. Now, if he has defaulted, it means his financial standards have undergone some deterioration. So the firm characteristics over here would be in terms of deterioration in their financial matrices, right? So obviously they have undergone certain deteriorations, and hence, in the long run, what they have done is they have gone ahead and they have defaulted, right? Now, when they have actually defaulted, the next part that comes out over here is the following: that apart from this part, apart from okay, so what I have over here is the, yeah. So like firm characteristics. So what type of firm characteristics would come in to explain my recovery? So to explain my recovery, as I said, we would look into the deterioration in the behavior of the firm. So what are the deterioration matrices? Now, if you are talking about recovery, now now you have given loans to two firms and two have defaulted. Now you are trying to recover money from them. So the first question that comes out is that which is the firm who is more likely to return your money back? Now that firm will be able to return your money back who has defaulted, but their deterioration in their capability of repayment has been relatively lower. Now, if it's a firm, how do you make an idea about that? So, so some of the deterministic factors that we are talking about would be captured in terms of degrading. So one of the important characteristics is degradation in the credit rating. A firm which has degraded, right, more in terms of credit rating, right, at the time of default, will be a more riskier firm. So you would be able to generally recollect back a relatively lower amount from this particular firm, right? So there is this degradation. So degradation in the credit rating. Now, the next thing that I have over here is, so once you talk about degradation in credit rating, so similarly there would be degradation in their financial standards, right? So in some of the financial ratios, what are the financial ratios? What are the key financial ratios that we can look into? So obviously one of the issues would be, okay. So let's say a degradation in the cash flows of the firm, right, in the free cash flows, or degradation in the key balance sheet concepts, in the key balance sheet components of the bank, of the borrower, would lead to, or would be the explaining factors in estimating the recovery that the firm, that the bank can make from that particular obligor firm, right? Now, apart from this, there will always be a random factor, right? Now, random factors are those factors which would kind of originate randomly. So it is not that there is any sequence to their occurring. So they occur just randomly out of it, and it is this occurrence of this randomness which makes this model which makes the predictions, or which creates a drift between the actual and the predicted values. Because if this error term of this random factors was not present there in explaining anything, so in explaining the dependent and independent variables, then you would not need to make any predictions. You would, from the historical values, you can exactly compute the future value, but you cannot do that because there is a random component involved. Let's say, let's say that you have, so you have two borrowers, right? So one of them who have undergone relatively lower deterioration in terms of the key components, but suddenly when you are trying to recollect from them, some issues happen because of which you have to bear a huge cost, and your recollection and your collections go down by certain percentages, right? So there can always be random factors. So randomness in this part express the uncertainty associated with any of these processes. Right? It represents the uncertainty. Okay. Now, before I move on, there would be so there's a question from Kiran which I'll take it up. Yeah, yes, that like the banks purchase bureau data for retail customers. Do they purchase such data for firms? And if so, who are the providers? Uh, I'm not sure about that, Kiran, that whether do they purchase bureau information for the firms or not. But yes, I believe that when they are developing acquisition models or any such kind of similar kind of models, and they have small and medium enterprises who do not have sound balance sheets, they want to develop the businesses, they expand their businesses, and try to make it more sounder. Then they look into these commercial bureaus, right? Now I'm not sure who are the exact providers, right? Who exactly provides, but there are cases when the banks do use the uh, you know so do use bureau or third party data. But when you have but mostly what happens is that when you have these so if you think about the Moody's tools, right? If you think about the Moody's tools, then you can see that the Moody's tools generate some of these has or they have data listed with of list firms. For listed entities, it also has the what would I say? So for the listed entities, the ratings of the firms are also available, and then you also have the balance sheet of the firm operating over the last few years, whatever the years of operations are. You'll have the balance sheet of that particular firm, right? So from the balance sheet, you can actually make it out whether the firm has undergone a deterioration or an improvement, right? But I need to check about the exact providers of the data, but I do know that there are certain providers and banks under certain cases do extract variable from a third party source. But I think it is like uh, Equifax or Experian. They do provide commercial data as well, but I just need to check that. Fine. So the next question that comes out over here is that fine. So the yi, so the dependent variable is explained by two set of factors, the deterministic factors and the second is the uncertain random factors, and the objective of the model development of the regression model development is to minimize the impact of this random variable on the predicted values, right? So this part needs to be minimized. So the impact of this needs to be minimized, right? Now the linear regression approach is an approach which helps us do that, or helps us minimize the dependent and the independent variables. I mean, helps us minimize the error in the prediction by helping us minimize the random random or the uncertain component, right? So the next question that comes out over here is then how do we do a linear regression model? So that is the next part. So what are the key components? What would be the core components of a linear regression model? And when is it that we can do a linear regression model and when is it that we cannot do a linear regression model and we have to try out something new? So this is the first thing that I would try to explain. So So if you have a look into the equation that a linear regression has, it says that yi is composed of two parts. One is the expected value of y given x. So expected value of y given x implies what? Expected value of y given xi implies that, I'm trying to so it is the average. Which is the expected value of y given x equal to xi plus ui. So, so over here, what I'm saying is that the express so yi is comprised of two parts. One is the determinant, the average component. So where I'm trying to look into so I'm trying to predict the expected value that yi has given a particular value of xi, right? If I have some variables, so given a particular set of values of xi, I'm trying to compute the estimated value of yi. So expected value of yi given x equals to xi is the deterministic or the average or the expected component. So it is this part which we try to predict, right? And yes, you can say that yi equals to a plus b xi plus ui is the formula for the linear regression equation. So it is this part that I would try to predict. Okay, so Kiran has a question over here. Here we are trying to build two LGD models, one predict loss and forecast loss amount. Am I correct? Yeah, Kiran, so you are more or less correct. So basically, we are trying to develop, not, I mean, so our objective is to develop one final model, right? But we are trying to explore different ways. Now, one way to look into the LGD problem is to understand that whether there are charge-offs in the next 6 months or otherwise. If you have a charge-off happening in the next 6 months, you'll have a loss. So you'll have a loss given default. If you don't have a charge-off, so you know that then the chances of loss given default would be lower. On the other hand, what I'm trying to do is I'm trying to find out in an alternate manner that how would I estimate the LGD. So the LGD can be estimated by estimating the recovery rate. If I first estimate the recovery rate, right? They estimate the recovery. From the recovery, I estimate the recovery rate, and 1 minus the recovery rate will become my LGD. So over here, another the alternate approach would be to predict the recovery, right? And when you're predicting the recovery, what you can actually do is you can actually identify the factors which help you predict the overall or the average behavior of the recovery, right? Right? So these are two alternate ways through which I am trying to reach out to one common solution. So the first way to which I am looking into it is trying to predict the expected value of y given conditioned by the values of xi, conditioned by the set of values of xi. So given a set of values, this is the average recovery that you are expected to get, right? So now the first question that comes out is that if I need to do this prediction, what is the requirement, right? So before we go into the requirement, we need to understand a, an important concept. This concept, this UI, is a random term, right? So how do you define the randomness? How do you bring in the randomness in the model? You say that UI follows UI follows normal distribution. So what we say is that UI follows a normal distribution with a mean 0 and a variance sigma square t, right? So UI follows in with mean 0 and a variance sigma square. So the moment I say this, I am then defining this UI as a random process. Now why is this normal distribution with mean 0 and a constant variance, right? Why is this a random series, or how do I relate it to be a random series? Because this is an important interview question, right? So one important question that they ask over here is that, hey, look, you say that UI is normally distributed, right? And you are saying that UI should be random. Now, can you show that if UI is normally distributed with mean 0 and a constant variance sigma squared t, can you show that, or can you tell me that UI is kind of, non, so that UI is random in nature? So can you just relate between the two? So the only way, a very easy way to show this is that if a normal distribution satisfies these two characteristics, right? If it has a mean 0 and a constant variance, then it cannot have a specific pattern, right? And the movement of this is absolutely random. So how do I show that? So the easiest way to show that is just to draw a diagram. So over here, okay, let's say that this is the zero mark. Let's say this is your zero mark, right? Now over here, so this is the mean. Now you have a constant variance. Let's say plus 2 over here, and you have a minus 2 over here. So if your variance is 2, it means that your deviations remain between plus minus 2. So it starts from the first one. Let's say that the first one starts from 0, reaches this. So over here, one thing that you can see is that there is no pattern in the movement of of the variable, right? So if your variable has a mean zero and it has a constant variance where it's very constant up and down with a given amplitude, you know that this variable is not something that you would want to use. So this variable is not really something that you would want to have with you in your work. So this is something which is really random in nature. So this variable on its own cannot explain anything. And and since it is a random variable, you need to actually minimize the impact of this variable on the right. So given that it cannot predict anything on its own, so I what I need to do is I need to minimize the impact of this on the predictions. Right. Now the question that comes out is how do I do that? Now, before I go into this, there is another important question that we need to understand is that what is this expected value y given x equal to xi? So it says that what is the expected value or the average value of y given a particular set of xi's. And over here, the assumption is that this expected value should be proportionately related to the x values. So that is the reason why we write it as a plus bx. So what I'm saying over here is that the deterministic component, that deterministic component is proportionately related to the variable x. So when you are trying to predict or when you are trying to develop a linear regression model, all you are trying to see is that if I try to approximate the given scatter plot that I have with y between y and x, a linear line should be able to best approximate the scatter plot, right? Now if that so if the scatter plot does not fit that linear line well, then what we can say that yes, there is some misalignment or there are some alignment issues. So so basically my objective over here is to use this x to predict the y, and while I'm doing so, to minimize the impact of this ui on my prediction. So the first question that comes out over here is that what should be the key characteristics of the dependent variable and the independent variable. So the first question that comes out is what is exactly the distribution of this variable yi? What should ideally be the distribution of the variable yi? So what I want to know over here is that what exactly is the distribution that yi has, right? Because the distribution of yi will help me understand the choice of the appropriate method. So over here, one very important part is to assess the distribution of the variable. So let's try to think about it in this way. Once I know the distribution of the dependent variable, only then can I use this distribution to, you know, so only then can I decide upon the choice of the appropriate measure of model development. Right? So over here, So first of all, let's try to understand that what should be the appropriate distribution that yi should have, right? Now, because this treatment, this choice would actually lead you to make your prepare your data accordingly. If you're preparing your LGD data, right, your observed LGD series, which is charged up by the exposure at default, would show or should be prepared in that way, right? So it is very important that you understand what the distribution or what the actual distribution of your charge offs look like, right? So, so the question that comes out over here is that what is the distribution of this independent variable yi? Okay. Okay. So before I start off with the distribution of yi, just give me a minute's time. I'll be back and we'll get started. Just give me a minute. Okay. So basically, what I was saying is that if we are trying to develop the models, right? So the first thing, before we decide on the choice of the models, the first thing that I need to understand is how is it that the dependent variable is distributed. Now, if the dependent variable is not a symmetric distribution, then you know that there is kind of a challenge, right? Because so, and the challenge would arise from the fact that if the distribution is not symmetric, then using linear regression would not help much, right? Because given the distribution of the dependent variable, you need to prepare your data sets accordingly, right? So this is the part that we would be talking about over here. So basically, let's say that I have this equation over here, yi is equal to alpha plus beta x plus ui. ui. Okay. So to assess a distribution, we need two things. First, we need to understand its mean, right? How do we compute its mean? Its mean is computed using expectations. So expected value of yi, expected value of yi will be equal to, now alpha and beta are numbers, right? So alpha and beta numbers. X is non-stochastic. So x is a provided value. So obviously expected value of this alpha plus beta x is a constant. So alpha plus beta x will remain as is, because if you take the mean of a constant, it is nothing but the number itself. Now plus expected value of ui. Now the average of the expected value of the random term, as we have seen, is 0, because the positives and negatives just cancels out, and what you have is 0. So over here, the expected value of yi actually turns out to be alpha plus beta xi. So which means that this is the mean of the series, beta xi. The next part that I have over here is, Now the next part that we do over here is we need to look into the variance of y. What is the variance of y? The variance of yi is yi minus the expectation of yi. That is, when you compute the variance, what you do is you take the difference of the observation from its mean, you square it, and you take an average of it. So basically, yi, expected value of yi, is nothing but alpha plus beta xi plus ui. So observed value of yi is alpha plus beta xi plus ui minus alpha minus beta xi. Now the mean was alpha plus beta xi, so if you open the bracket, it is alpha minus alpha minus beta xi. So everything cuts out, and you only have expected value of ui square, which is nothing but okay. Over here, what I get is the expected value of ui square, and this becomes sigma square or sigma square u. So now over here you can see that both the mean and the variance of this distribution is of the distribution of yi is constant. So one thing that we can say is that for a logistic regression model to be developed using a linear regression, the first thing that you need to do is you need to so the first thing that you need to do is you need to kind of okay. So what we so if you want to develop a logistic regression, so if you want to develop a linear regression model, right? So if you want to apply linear regression to solve or to develop an LGD model, you need to ensure that the dependent variable is normally distributed. Now, if the variable is not normally distributed, then you cannot. So if it is not normally distributed, then it would not be possible for us to develop the model using a linear regression approach, right? So basically, this is a very important binding, important implication on the preparation of your data. So when you are preparing the data, you need to ensure that the dependent variable is symmetric. So if you have a LGD, or if you have a recovery series which you are trying to predict, then yeah. So as I was saying, that if your dependent variable is not continuous in nature, that is, if you are unable to so if your dependent variable is not if the dependent variable is not symmetric in nature, then you cannot use linear. regression, right? So for a skewed distribution, use the beta regression. For the skewed distribution, so if you have a skewed dependent variable, that's where the story of the beta distributions actually come. So what we have over here is we have the skewed distribution, right? So now the next question that comes out over here is the following: that in case of a skewed distribution, how do we develop the regression model? Now, if it's a skewed distribution, right? If it is a skewed distribution, then we use the beta regression. So one advantage of the beta regression is that the output that it gives is between 0 to 1. So this is the second test that we would look into. So over here we see that there are these three approaches, right? So first we saw when is it that we can use logistic regression to develop the model. Second, what we are seeing over here is when is it that we can use linear regression. The third is when is it that so when the distribution is skewed, right, for LGD, how do we predict that? So these are the three broad approaches, right? So when you are trying to and if it's logistic regression, your business problem is like y equals to 1 if the charge off happens next 6 months equal to 0 otherwise. So given that there's a probability of a charge off, a high probability of charge off, you know that okay, this is the borrower who is going into default, right? So from that you get your for that record you can actually estimate given that probability of the charge off you can actually find out given that the account charges off, right, what is the loss that is likely to be incurred from that record. These are the three broad approaches. Now the question that next comes out over here is that what or how should the data be prepared. Now we have talked about the data requirements previously for LGD model development, right? So can you tell me what type of accounts would appear in an LGD model development? So what type of records would I require for developing an LGD model? Yes. Okay. So just to refresh, for LGD model development, the dataset that I would use would contain customers who have defaulted, right, Kiran? But when I'm talking about defaults, what is the type of defaults? One is accounts which were snapshot defaults, let's say who are defaulting right this month. Also, I'll have accounts which have defaulted last month, right, but still appears in the books of the bank, right? So all accounts which have defaulted will be my model development base. And when I talk about default, The typical default definition is so a typical default definition would be a 90 days past due, or if the borrower is has undergone troubled restructuring, or has been put into payment plans, or it has or when account has been written off from the books of the bank, or some forbearance activity has happened against it. So accounts which have been suddenly closed because of certain factors that they've defaulted, or accounts which have defaulted in terms of 90 days past due, or accounts which have been under payment and restructuring activity. So these are accounts which form your LGD model base, right? So the dependent variable over here can be a recovery variable, as it's in the linear regression model. It could be the charge of variable as we had seen in the logistic regression model and so on. So there could be multiple issues. Now comes the next part, that the data preparation part. Right? Now, for the data preparation part, now one very important part in LGD model is to prepare the recovery data. Is to prepare the recovery data. Okay, so one of the biggest challenge of engineering model development is to prepare the recovery data. And what are the challenges that the recovery data can face? Now, one challenge is obviously non-maintenance of records. So always it is not the case that all recovery records are currently. So it is not always necessary that all the data is currently updated. So there can be a lag in the updation. The next question that comes out over here is that in this recovery data, what is it that we are trying to do? So over here, what we are trying to do is we are trying to understand this recovery. So basically, in this recovery data, what is it that we are trying to do? We are trying to ensure that all the variables are there in place. Now, recovery data is one of the risky data in any organizations, because what happens. Recovery happens at many stages, and often when a recovery data is outsourced, right? Some recovery is going outsourced to these collection agencies, right? So these collection agencies often face issues in or you know reporting lags and stuff, because of which the recovery data gets affected. So if you are actually working with this, so pulling in or managing the recovery data itself would be a very important job, right? So often the recovery data faces or struggles from the issues of incompleteness. So that's one part of the story, right? Now the second part of the story is your performance in the LGD model. The performance period in an LGD model would be based on the performance which is there in the data. So which is there in the you know so in the recovery data. So so basically the performance period. So in LGD model don't have separate performance periods like as in PD or EAD model, because I know the account is already defaulted. So my performance period is applied on the recovery data, right? So within how many months will the collection be completed? So that is a very important part. So So looking into the cumulative recovery curves, trying to identify the cut-off month where so which would be the recovery performance, right? So for retail unsecured products, it is around 48 months, and for retail, you know, and for others, it's mostly like 36 months. So 36 to 48 months is more or less what we get to see as a recovery time. So the time taken by the bank to sell off the product, right? Now, so basically, when we are preparing this data, right, the recovery data, we need to ensure that the recovery data is more or less symmetric in nature, and that is why you know the box-Cox transformation would be there. So the box-Cox transformation would help you not only making the system continuous in nature, but also it would help us work with the variable which has been relatively or appropriately transformed. Now, the next question that comes out over here is that if the recovery data is not symmetric, then what do we do? Then what we do is the beta regression. So the beta regression is applied on an asymmetric distribution, right? Is on an asymmetric distribution where so the beta distribution is an asymmetric distribution where the output is between 0 and 1, and because and because the probability of default over here is a similar problem, right? So therefore, there would be similar approaches which would kind of help you to get the result. So basically, since beta regression puts out 0 and 1 as its output, it is a very favored measure of regression, right? So our next step over here would be to understand each of these three regressions, right? To understand what the logistic regression is, what the linear regression is, and what the beta regression is. Now, logistic regression would not be discussed over here because we'll have separate discussions for them. So, what we'll talk about over here is, or what we focus mostly here is, we focus on linear regression and beta regression. Clear? Fine. So let's try to check as to what this recovery data is like, or let's try to check what the beta distribution is like. How does a beta distribution look like? And once we have seen how the beta distribution looks like, the next thing over there would be to understand what is this beta regression and why is it better, right? Also, before that, we'll do a very quick recapitulation of the linear regression model. So the question that comes out over here is, I have said that before I run a linear regression model, I need to ensure that the dependent variable is continuous in nature, right? And not only continuous, ideally it should be normally distributed. And this is a follow-up characteristic of the distribution and the variance of the borrower. Okay. Okay, so any questions up to this one? So how does the beta distribution look? So I'll just bring in the concept of beta distribution. We'll close today, and then tomorrow we'll parallelly develop the linear regression and the beta regression, and we'll see why is it that linear regression is suited in a normal so suited when your dependent variable is normal, and why is it that beta distribution is suited when your distribution is uh, skewed, right? So this is what we will talk about in tomorrow's discussion. So tomorrow I'll take a class at the same time. Okay, fine. So over here, so let's first see what a beta regression is. So a beta regression is a simple skewed regression. It's a skewed regression. If your dependent variable is skewed, then what you do is you use a regression of the type of beta regression. Now, the question that comes out over here is so two things. First, why is it that I will use beta for or a beta function for or why would I use a beta regression? So in a beta regression, right? The function that I use is a beta function. What is a beta function? A beta function is a very specific probability density function, right? So it is a mathematical function which represents the probability distribution of a skewed variable. And how does it look like? So how does the function look? The beta function looks something like this. So it says something like this: x it's like x minus a, the power of q minus 1, b minus x to the power of q minus 1. minus 1 divided by sorry, beta. Sorry guys, I just lost out connectivity. Right? So over here, so this is how the beta function, the probability density function, or the functional form of the beta function looks like, where this is the beta function, this is the beta function. So we'll start with the description of this beta tomorrow. So we'll see that how is it that this distribution is a skewed distribution. How is it that we can prove that this distribution is a skewed distribution? So that is what is going to be the next part of our discussion, right? So we'll take up both these two functions together, the beta functions and the linear regression, and we'll walk through both of them and we'll see which is a symmetric variable, symmetric one, and which is asymmetric one. So we'll do a comparison, and from there we'll try to choose that which is the one to be used for model development and when, right? So let's catch up tomorrow and let's take the show forward. So thank you guys, thank you for your time. Let's catch up tomorrow. Have a great day ahead. Bye bye.